Okay, for today, we're going to continue our review of quadratics, and we're going to talk about vertex form for today. We actually saw vertex form yesterday when we were graphing, because vertex form is the form that we learned how to graph from. So that's why we saw a bunch of vertex form yesterday. So this is something that we've seen already in this packet, and it's something that we're familiar with. So we're going to do a little more work with vertex form for today. So vertex form is called vertex form because it tells us what? The vertex, right? They're not trying to be tricky. It tells us the vertex. Okay, vertex form tells us the vertex of the function. The most sort of generic version of vertex form that we can get would be something that looks like this, where I've got no values plugged in for anything. Just all placeholders, okay? Remember that A value tells us about the shape of our graph. So if it's negative, that means we're flipped upside down. If it's a half, that means we're going to be kind of smashed. Compressed was the word that we used. If it's 2 or 3 or something like that, we'd be stretched out. And then H and K are where we look for the vertex. So the vertex of our function would be H, comma, K. Whatever those values are, whatever I see here and here. Now I want you to notice, and we saw this a little bit yesterday, that whatever sign I have on H, it's the opposite here. So this is X minus H, but when we go to write our coordinate, it's just H, okay? So we get our vertex from vertex form. Now we're gonna do some converting into vertex form today. So in order to convert to vertex form, that means we already have a different form that we're starting with. So what we're gonna start with for today is something called standard form. You have also seen standard form before. Does anybody remember what standard form tells us about the graph? Yeah, the y-intercept. Standard form tells us the y-intercept of the function. Our most generic standard form is y equals ax squared plus bx plus c. The a here is the same as the a here. So if this is -2, this is also -2. It's the same value. And then where do I look to see my y-intercept? Look at C. Yeah, my y-intercept would be 0, comma C. Whatever that C value is, my y-intercept. The very first thing that we're going to do today is just practice identifying these different function forms and then what information they give us about the graph. What I found when we went through our quadratics unit the first time is that if we were only working on standard form, you guys could knock it out of the park. If we were only doing vertex form, you could do 1,000 vertex form problems, identify the vertex every time, no issues. Same with factored form, which we'll talk about next time. But the issue is when they're kind of jumbled together and you have to stop and think about what you're seeing here. So that's where we're going to start for today. What am I looking at? So for our first little block of problems here, our first little section, I want you to tell me which function form we're looking at. We're only talking about vertex and standard form today. So which are you looking at? And then what does it tell you? What's the key feature that you get from this function? So for example 1, what form is this function in? This is standard form. Very good. And what does standard form tell you? The y-intercept. And what is the y-intercept for this problem? -4. Yeah, our y-intercept is -4. If you just tell me the y-intercept like this, that's fine. If you would rather write it as an ordered pair, 0, comma, -4, that's also fine. How about example 2? What function form do we have there? That's vertex form. Good. That's vertex form. And what does vertex form tell me? The vertex. And what is the vertex for this function? Good. -2, comma, -3. Remember, be careful with those signs for the x coordinate. How about example 3? What function form is that? Standard. You call this standard form. What's the y-intercept? I'm sorry, what'd you say? 4. Anybody disagree with calling this standard form? Yeah.
The only reason why I said vertex was because I didn't see any numbering on the x, but it was thought of that as vertex and then it would be 4. So it's
Yeah, we could also very reasonably call this vertex form. So you're saying there's no B term here. That's what I would look for to say definitely it's standard form. So this is standard form, but it is also vertex form. So what's the vertex if we identify this as vertex form? 0, 4. Yeah, I don't see anything in parentheses with the x here. That means the x coordinate is 0. So 0, 4 for the vertex there. How about example 4? What form is that? Mm-hmm.
wouldn't it be vertex, it's just no other like dx or c.
So you're telling me this looks more like vertex, okay? And then what is the vertex for this guy?
It'd be 0, 0.
Good. 0, 0. The -3 in front tells us about the shape of the graph. Was anybody going to tell me something different than vertex form? Saw some other hands. Would anybody have called this standard form? If you would have called this standard form, you're absolutely right. This is also standard form. So here, our B value would have been 0 for standard form. Here, our B and C values would be 0, just like our H and K values are 0 if we call this vertex form. So this one I could also call standard form. So a little bit tricky that I can give it multiple labels, but if we're talking about finding key features, it actually makes it a little easier to find more key features when I've got sort of these kind of hybrid in between versions. So if I call this standard form, what's our y-intercept? 0. Yeah, I don't see anything here. I don't see a C term here. That means it's 0. Questions for me so far? So again, a little tricky on 3 and 4 since they fit both descriptions. What I want you to remember, standard form tells you the y-intercept, vertex form tells you the vertex. So what we're going to spend the bulk of our time on today is being able to swap between different forms here. So the first thing we're going to look at is changing something that's already in standard form into vertex form. When we worked on these problems in our regular unit, for the most part, you guys did really well with this. Just where we got tripped up was the vocabulary that we saw in the directions. So you'll notice here, we're going to change from standard form to vertex form by completing the square, and it's giant and it's underlined because this is the part that tripped us up in our regular unit, okay? That's the name for that process. It's called completing the square when I change from standard to vertex form. That's the part we had a hard time with. That's why it's giant and underlined here, okay? We see it again, and remember that this means we're changing to vertex form, okay? So completing the square is the name of that process. So the process itself is not something that most of us had a hard time with. It was just remembering what completing the square meant. So to complete the square, that's where, again, I want to change to vertex form. And we change to vertex form by identifying our B and our C in standard form, because those are the two important things that I'm going to need. What I'm going to do is take my B value and cut it in half. So I've got 4, cut that in half, I get 2. And then I put X plus 2, since it was positive 2, in parentheses with X, and that's what gets squared. That's what makes that part in parentheses for our vertex form, okay? And then we keep the C that we have. That's why I need to know what C is. C is -2, so I'm going to keep the C that I have, but then there was an adjustment that we had to make, right? So X plus 2, remember, would mean X plus 2, or I should say X plus 2 squared, would be X plus 2 times X plus 2. And so if I distribute this, right, this is what I have right here. That's what I've written right there. If I distribute this, I get X squared plus 2X plus 2X plus 4. And so if I combine like terms here, I get X squared plus 4X. Well, that's perfect because that's what I already have here. And when I rewrite to these different forms, it should be the same function, right? If I don't have the same function, if I don't have the same pieces, that means I've changed it. We don't want to change anything. We just want it in a different format so we can find different stuff for the graph. So this part is great. The part that I have a problem with is this plus 4 at the end. And that's where I had to make an adjustment, right? I'm adding 4. When I write X plus 2 squared, I get this extra plus 4 that I don't want. So to correct for that, at the end, we subtract it off. I'm adding an extra 4 here. I can sort of cancel it out. I can negate it if I subtract 4 at the end. Okay, and that was that adjustment that we made. And then to have vertex form, we just kind of tidy this up. So x plus 2 squared, and then combine your like terms at the end, -2 and -4 would be -6. So there's our vertex form. We're going to do it again with example 6. So again, I need to identify my B and my C. Those are the things from standard form I need to write vertex form. And this is going to start with x in parentheses, and then to finish what goes in parentheses that I'm going to square, I need to find that B value from standard form and cut it in half. So -6 cut in half, that'd be -3. I want to pause here for just a second to point out that whatever sign I have on my B in standard form is the same sign I get in vertex form. So that H value, that number in parentheses of x. So since this is positive, this is also positive. Since this is negative, this is also negative. That sign should stay the same. Okay, so B cut in half. I keep the C that I have, so I'm going to keep that plus 10. And then again, I need to subtract that cut in half number squared. It's always going to be that cut in half number. If we take a peek over here, here is my cut in half number, right? 4 cut in half was 2. And then no matter what the rest of the problem is like, no matter, like it's always going to be x, it's either plus or minus, that part doesn't really matter. But what's going to happen is at the end of that distribution, I would do that cut in half number times the cut in half number. And that's how I get this thing. Well, a number times itself, we say that's squared, right? So that's why it's always the cut in half number squared. And that's true even if it's minus. Here it was plus. For this one, it's going to be minus. It's always going to be subtracting the cut in half number at the end because, remember, x minus 3 times x minus 3 here. I don't care about the first part of it. If I look at the last part of that distribution, -3 times -3 would give me +9. So I'm always going to be adding in that extra thing, which means to correct it, I'm always going to subtract that cut in half number squared. So this would be -9. It doesn't matter what the sign is in here. I'm always subtracting the cut in half number squared. Okay. And then we'll tidy this up. I get y equals x minus 3 squared, and then 10 minus 9 would be 1. So there's our vertex one. For example 7, same idea. Here's my B, here's my C. Remember, I want standard form, so everything in order, like terms combine, all that good stuff. And then what we're going to do is take that B value and cut it in half. So -2 cut in half is -1. So I have x minus 1 squared. Keep the C that we have, which is 4. And then subtract our cut in half number squared. So 1 squared is 1. Then tidy this up by combining those like terms at the end. So we get y equals x minus 1 squared plus 3. And then one more time for example 8. Here's my B, here's my C. I'm going to start by cutting that B value in half. So 10 cut in half is 5. So I have x plus 5 squared. Keep the C that we have, so -2. And then we subtract our cut in half number squared. 5 squared would be 25. And then we tidy this up by combining our like terms at the end. So I've got y equals x plus 5 squared minus 27. Question?
On example 7, would it be +1 or -1?
-1 squared is +1, right? That means that we're adding an extra 1 here. So I correct it by subtracting that extra 1. Just like here, right? -3 and -3 is +9. So I have to subtract that 9. Okay. Before we move on, really quickly, what's the vertex for number 7? What would be the vertex for this function? 1, 3. Good. What's the vertex for number 8? Yep, -5, -27. Other questions for me so far? Okay, go ahead and turn the page. Now we're going to go the other way. So we went from vertex to, or from standard to vertex form. Now we're going to go from vertex to standard form. We can go one way, we can go the other. So at the top of page 5, we're going to change from vertex to standard form by this time distributing. So completing the square is how to get to vertex form. Distributing is how to get out of it. So remember, distributing means multiplying, right? Something with a quantity, something in parentheses. So what we see here with our vertex form is we've got something in parentheses squared. When I square something, that means that thing times itself. So that's what I'm going to write out. X plus 1 times x plus 1. So anytime I want to change from vertex form back to standard, I'm going to take the thing in parentheses, that squared thing, I'm going to write it twice, and then we're going to distribute. So x times x gives me x squared plus 1x plus 1x plus 1. And then don't forget the minus 2 that's hanging out at the end here. Once we finish all of our multiplication, combine like terms. So I would get y equals x squared, 1x plus 1x would be 2x, and then 1 minus 2 would be negative 1. There's my standard form, x squared plus 2x minus 1. Example 10, same idea. Take that squared thing and write it twice. So x minus 3 times x minus 3. Don't forget that plus 1 at the end. And now distribute. X times x is x squared minus 3x minus 3x plus 9, and then plus 1 at the end. I'm all done multiplying, so now I'm going to combine like terms. So I would get x squared minus 3x is minus 6x, and plus 9 plus 1 would be plus 10. Questions for me so far? Okay, now 11 is a little bit trickier because I have an a value there that's not 1. For each of these, my a value, my lead coefficient would just be 1, but here for 11, I've got 2. So from our graphing work, we know that that means that this parabola would be stretched, right? Those vertical distances to get to my next point would be doubled, multiplied by 2 here. When I go to change this into standard form, though, it means I've got an extra step. I want you to start this the same way that we started 9 and 10. So I'm going to start by rewriting the squared part as 2. Okay, so I've got 2 times x plus 5 times x plus 5. Write the squared thing twice, and then that minus 11 at the end. And then again, I'm going to distribute the stuff in parentheses. I'm doing this exactly the same way we did the last couple of examples. I'm going to start by multiplying these two together. X times x is x squared plus 5x plus 5x plus 25. And now I've got 2 times this stuff, so I'm going to write that here, 2 times this stuff. And then we've got minus 11 at the end. Just like I said for the last couple of problems, I'm not going to worry about combining like terms until I'm all done multiplying. I'm not done multiplying yet. We have this 2 in front that we need to multiply now. So I'm going to distribute the 2 to everything in parentheses. This would be 2x squared plus 10x plus 10x plus 50, and then minus 11 at the end. Now that I'm all done multiplying, I'm going to combine like terms. So I get y equals 2x squared, 10x plus 10x would be 20x, so plus 20x. 50 minus 11 would be 39, so plus 39. Now, the reason I want you to save the 2 for the end and do these first is because what I have seen is that if we try to distribute the 2 ahead of time, we forget to write the thing in parentheses twice, and you distribute the 2 in here, and then you tell me 2x plus 10 times 2x plus 10. And what that means is you've actually multiplied by an extra 2. That's why I want you to write this twice and do this distribution first. I want you to keep it in the same sort of sequence of steps, keep it in the same format as the other one. Okay, that way we distribute this. We don't end up with any extra 2's in there. Questions for me on example 11? Okay, let's look at 12 then. So 12 is like 9 and 10. I've got no visible lead coefficient here, nothing to worry about multiplying in. So I'm going to take that squared thing and write it twice. X minus 4 times x minus 4. Don't forget the plus 3 at the end. And distribute. So x times x is x squared minus 4x minus 4x plus 16, and then that plus 3 at the end. Since we're all done multiplying, I can go ahead and combine like terms. So our tidied up version here, our standard form would be x squared minus 4x would be minus 8x, and then 16 plus 3 would be plus 19. So x squared minus 8x plus 19. Questions for me on changing to standard form? Okay, so the last thing that we're going to do today is really similar to some questions that you saw on the Unit 8 test. So on the Unit 8 test and on the Unit 8 quiz, I gave you a function and then I asked you for 2 different pieces of information about it. One of them you could get from the form the function was already in. One of them you had to change it to another form. Okay, so we're going to see that here. The only thing that I've added in for these problems is I've asked you to tell me what form the function is in right now. I think this is a part that we skip over sometimes. And again, like I said, if you are only doing vertex form stuff, then that's pretty easy. If you're only doing things with factored form, which we'll talk about next time, or you're only doing stuff with standard form, then it's not a big deal and you don't have to stop and pause to think about it. But when they're all jumbled up and you're looking at different function forms with each new problem, then you need to pause, think about what you've got, and think about what you know about your function, about your graph, based on that function form. Okay, so that's kind of what I'm doing here. I'm forcing you to pause and think about what you've got. So for 13, this function is in what form? This is in standard form. Since it's in standard form, what do I know? I know the y-intercept. What is the y-intercept? 3. Okay, so I want you to pause every time you're working with quadratic functions. Pause, think about what function form you have and what you know because of that. Okay. Now the other thing I want is the vertex. So that means I need to change this into vertex form. So we're going to complete the square here. So remember, I need to know my b and my c. Okay. So what I'm going to do is take my b value and cut it in half. 4 cut in half would be 2. So I have x plus 2 squared. We keep the c that we have, which is 3. And then we subtract our cut in half number squared. So 2 squared would be 4. So we're going to subtract 4. Now I'm going to tidy this up by combining my like terms at the end. I get y equals x plus 2 squared minus 1. Now I've got vertex form, so we can identify the vertex. What's the vertex for this function? -2, -1. Very good. Questions for me on 13? Okay, let's take a look at 14. Same idea. We're going to start by asking ourselves, what form is this function in right now? This is in vertex form, so that means we know the vertex. And what is the vertex? 3, 5. Good. The other thing I want to know is the y-intercept. So that means I need to change this to standard form. So we're going to distribute just like we did at the top of page 5. So I'm going to take that squared thing and write it twice. And distribute. X times x is x squared minus 3x minus 3x plus 9 plus 5. So we'll combine like terms here to tidy this up. We get x squared minus 6x, and then 9 plus 5 would be plus 14. So what's our y-intercept? 14. I would like you now to try examples 15 and 16. At the bottom of page 5, try examples 15 and 16. Okay, let's take a look at these. Example 15, what form is this function in? This is standard. So what do I know? What is the y-intercept? My y-intercept is -6. Good. Now to find the vertex, I have to change this to vertex form. So we're going to complete the square. Here's my b, here's my c. Take my b, cut it in half. -8 cut in half would be -4. So x minus 4 squared. Then we keep the c that we have. So we're going to keep the -6. And then we have to subtract our cut in half number squared. So 4 squared would be 16. Now tidy this up. So I get x minus 4 squared minus 22 when I combine my like terms at the end. So what's our vertex? 4, -22. For example 16, what form are we in right now? This is in vertex form. So what's the vertex? -9, -5, good. And I want the y-intercept, so that means changing to standard form. So we have to distribute. So I'm going to take the squared thing and write it twice. X plus 9 times x plus 9 minus 5. And we distribute. So x times x is x squared plus 9x plus 9x plus 81. And then that minus 5 at the end. So when I clean this up, I get y equals x squared. 9x and 9x is 18x, so plus 18x. And then 81 minus 5 would be 76, so plus 76. What's our y-intercept? 76. Not too bad. Again, this should be familiar. This isn't the first time that we've done this. This is a refresher. Big thing I want you to remember, and again, talked about this already, but the thing that we struggled with was not the process of changing to vertex form, it was just that vocabulary, okay? So when we change to vertex form, that's called completing the square. When I switch back to standard form, I have to distribute.